Good day. Today we are going to answer a simple physics problem involving relativistic mass. Just to give you an overview, relativistic mass, which is studied under Einstein's special theory of relativity, refers to the mass of a body in motion relative to the observer. It actually has two working equations, but we will not consider this time the one on the left, in which relativistic mass is equal to the product of rest mass and the Lorentz factor, and we will use the other equation in solving the problem to be presented later. In this equation, relativistic mass is equal to the quotient of m sub o and the square root of 1 minus the quotient of v squared and c squared, where m sub o is the rest mass of an object, v squared is the velocity of a moving object, and c is the speed of light, which has a constant value of 3 times 10 to the power of 8. Now let us consider a sample problem. Calculate the relativistic mass of a spaceship that is traveling at 0.90 the speed of light outside the solar system if its rest mass is 1025 kilograms. Just like what we usually do, identify first the given values in the problem. So we have 1025 kilograms as the rest mass, 0.90 the speed of light as our velocity, and the constant value of the speed of light, of course. Now we are asked to find the relativistic mass of that spaceship. Here's what we are going to do. We will use this equation on the left and plug in the values we obtained from the sample problem. So we will have relativistic mass, which is equal to the quotient of 1025 and the square root of 1 minus 0.90 squared, since the value for the speed of light would now be cancelled. Performing the necessary calculation, we will obtain 2,351.51 kilograms, which is the final answer. Therefore, the spaceship with a rest mass of 1,025 kilograms has a relativistic mass of 2,351.51 kilograms.